Okay, the final problem today uses what's called the even and odd powers of x minus c theorem. I was not at the naming ceremony. This is one of the wordier theorems. But it's a nice theorem. It's really kind of cool. And it kind of touches on that idea that I just mentioned on the last problem, where maybe the graph touches the axis and turns back around, or maybe goes through. If c is a real number and the polynomial function p of x has x minus c as a factor exactly k times. Right? So if x minus c is a factor, that means c is a root, right? Just like example number 2 was. When we had the factored form, we said each factor equal to 0. If this factor is set equal to 0, x equals c is an answer. It's a root that touches the x-axis. If this thing is raised to some power, it's either going to be what's called an even root or an odd root. Even roots don't cross the x-axis. They touch and turn. Odd roots do cross the x-axis. So there's an intersection or not intersection thing. So if k is an even positive integer, c0 is going to be a point that the graph touches the x-axis, okay? But if k is an even positive integer, it will intersect but not cross. I like to say touch and turn. TNT. Touch and turn. I'll know what you mean by touch and turn. But again, as far as what a graph looks like, if I have an even power, let's say here's my graph, and let's say I have x minus 2 to the second power as part of my factored form. Okay? The graph, and let's say it's positive at the time. 2 comma 0 is an answer. The graph is going to come towards 2, touch it, and then turn back. If it's positive, it'll stay positive. If it's negative, it'll come up, touch, and turn and stay negative. Okay, it hits 0 for that one moment, and then it starts going back down. Or it hits 0 for that one moment, starts going back up. It doesn't change sign. So again, for an even power, that's how it works. If we're dealing with an odd power, odd positive integer, it still has a root at c comma 0. So let's say we have x minus 3 to the 5th power. All right? So here's 3 right here. Then I know that as it goes down here, then it's going to go through that one. If it started off positive like this, it would go up a little bit, then turn and go through that one. It's going to intersect, it's going to cross. Okay. So touch and turn or cross. That's what I'm looking for answers on these. The problems that they give you these, they're either are going to be factored, which is nice, or they're not going to be factored, which means you'll have to factor them first. But always factor with the intention of the same factor happens more than once, raise it to a power. Okay? So, looking at example 4, determine where the graph of p of x equals x plus 3 times x minus 2 squared times x minus 4 cubed crosses the x-axis, and where the graph intersects but does not cross the x-axis. So, first thing is to find the roots. X plus 3 equals 0, so x equals negative 3. X minus 2 equals 0, so x equals positive 2. X minus 4 equals 0, so x equals positive 4. Okay? Set each thing equal to 0. Don't worry about the powers in that step, just get the answers. So negative 3 plus 3 is 0, 2 minus 2 is 0, 4 minus 4 is 0. Give me the answers. And then the nature of the root at that point of intersection, at negative 3 comma 0, 2 comma 0, 4 comma 0, you look at the power. X plus 3 is to the first power, which is odd, so that's going to be cross. It's just going to go straight through the x-axis. All right? X minus 2 is being raised to the second power, which is even. That's going to be a touch and turn. X minus 4 is being raised to the third power. That's going to be a cross. If we add to that end behavior, okay, think about end behavior here. I don't have it in polynomial structure, right? The only one that matters to me is the highest power term, right? Yeah. This is x to the first, this will be x squared, that'll be x cubed. That's a total of x to the 6th power, right? So p of x, beyond everything else, is going to be 1x to the 6th power plus some other stuff. I don't know what the other stuff is. But when I'm doing end behavior, the only thing that matters is the highest power, right? Positive even power is up, up. Left and right. So if we consider this information in conjunction with this information, I'm trying to graph all this stuff, then let's see, get some graph paper out, get my x-axis drawn, get my y-axis drawn, and my points of intersection were negative 3, 2, and 4, so negative 3, comma 0, 2, comma 0, 4, comma 0. This was intersect, touch and turn, intersect, right? Up, up, and behavior. So I start off somewhere up here, I end up somewhere up here. It's going to come down cross, touch and turn cross. So I know that the graph's going to do something along these lines. Kind of missed that point, but there you go. Comes down, and it probably goes way down. You know, it probably does. I mean, honestly, it's probably way down there. The closer these are together, the slower it goes, or the shorter it is. So they're further apart, they go further down. Closer together, they won't go as far down. But again, there's a basic idea what the graph should look like. And again, if I verify that here, we have x plus 3 and then x minus 2 squared. Oops, x minus 2 squared. And then we had x minus 4 to the third. All right. And I'm going to set my window from -4 up to 5. I'll get all my zeros in there, right? Again, -10 to 10. I probably won't see the bottom of this, but let's just take a look. Intersects, goes way down, comes back up. Right at 2, we should see a touch and turn, and at 4, we should see a cross. And it actually did a little weird little, it came like this and kind of did a little weird, like one of those things. But again, I'm not getting a perfect graph out of it, but I'm getting some information from it that gave me some pretty good information. So crossing, touching, and turning. The reason this happens, sometimes we know why it happens, it's helpful. If we have an odd power, if x is less than -3, it'll be some sign. If x is greater than -3, it'll be a different sign, right? Yeah. So the sign changes in this here, and it's being raised from an odd power, so the sign change is going to create an overall sign change. Whereas if the sign change occurs in here, but we're raising it to an even power, the sign stays the same overall. That's why the even powers don't change. They hit 0, then they turn back because the sign doesn't change. For an odd power, if the sign changes in here, the odd power is going to have an odd number of those signs, so then you're going to get a change in the overall sign of the thing. So the negative changes to positive. Here, I've got a squared expression, so the sign's negative. The sign changed on the squared expression, it stays the same overall, so it's still negative. That's kind of what's going on there. So just believe in the theorem states very clearly what to do. Anytime you're asked to determine where it crosses or intersects but does not cross, you're using this theorem, and it's very straightforward. You find the root, and based on the power of that factor, it's going to do one or the other. Even power touch and turn, odd power cross. Your answer should look like this. There's no work to be seen, unless you have to factor. Then factor first, then there's no work to be seen. I know we can all get the answers without writing them down, and we can see odd and even without writing them down. So I'd expect answers like this for that topic.